That was fascinating. It's interesting. In March, I had a chance to visit TV Globo, and they are implementing some of these workflows with some of their apps, which is really phenomenal. Okay, our next session will be a easy-to-use solution for C2PA Workloads with Jonathan Solomon.
Well, it won't just be me. I've got Patrick here as well to do all the technical explanations. So welcome everybody. We're a little early, but we'll go ahead and get started because the only session worse than the one before lunch is the one before happy hour as a presenter. So hopefully everyone's still got their coffee going from previously. I am Jonathan Solomon. I'm a partner solutions architect with AWS. I'm focused on media and entertainment. With me is Patrick O'Connor, who's a prototyping engineer with AWS. Prototyping build really cool stuff to show that it actually works for our customers, and then develops it into usable solutions. And Patrick will explain that as we go through the this presentation. All right, I got the right buttons. So C2PA is the Coalition for Content Provenance and Authenticity. A lot of people think of this as the answer to deepfakes, and it's not quite what it's designed for. It's really designed to solve the complexities of tracking an asset through a supply chain, from ingest from a camera through distribution to a consumer device. Think of a web browser, for example. And the purpose is to validate that the asset you're working with, the media asset you're working with, is actually the media asset you think it is and hasn't been modified. So when I talk in words like that, people think, yes, deep fake, that type of thing. And that's true, but also think about that it's something in the edit process that has happened, that has caused us to change, cause a change in the asset. And you can track that through C2PA. So it's good to track authenticity. It's good to check provenance so you know where it came from and what's happened to it and who's touched it. It is in line with the responsible use of generative AI with guardrails and protecting the harmful content. And yes, with the advancing tools of an AI-powered content generation available to the consumer, it's easier than ever to manipulate your content as a content owner and purport that as their own or purport that for something it's not. And that is the spreading of false or misleading information. Very important to be able to identify that. So it's C2PA would allow content owners to demonstrate that this is or is not their content. This C2PA is a standard that is designed to securely associate provenance metadata with digital assets. It was founded as a coalition across Adobe, BBC, Microsoft, Sony, and more. And we're happy to announce at Amazon, the bigger Amazon, which includes AWS, became a steering committee member in 2024. There's one more note I want to read, so pardon me while I use my cheat sheet. It is a framework, and I can't memorize this one, so this is what I need to read. C2PA is a framework for cryptographically signing content metadata, allowing the origin, history, and transformation of digital assets to be reliably tracked. So that's the elevator pitch, reliably tracking through cryptographic signing. At AWS, we are working to have our services like Media Convert, Transcode, and Bedrock, which is generative AI tooling to integrate C2PA so it's seamless to the user. And we'll be showing today an open source project that we've created to help our customers try it out themselves or even deploy it themselves. This QR code coming up next on the next slide. One slide ahead, sorry about that. We'll talk about that, the C2PA workload on AWS. We were very grateful that St. Clair Broadcast Group who operates 180 TV stations, was ready to try this. They had a growing challenge of ensuring the authenticity and integrity of their content, and they wanted to make sure that content they had was their actual intellectual property, and also be able to monetize that content later on. They reached out to our prototyping team, Patrick and his team, to design a solution that would be cost-effective, yet very easy to operate, to both validate C2PA and to sign content with C2PA. We saw this as a way to show C2PA to a greater audience and to demonstrate the value with substantial backing from a substantial customer, a recognized customer. So there's the QR code. This is guidance for media provenance with C2PA on AWS. This is an open source project that Patrick and team have developed and released and maintains. We listened to Sinclair. We built this solution to meet their needs and to easily integrate into their supply chain. It uses services under the hood, such as Amazon S3 for storage, AWS Lambda, and AWS Fargate for compute, implementing a serverless media provenance solution based on C2PA standard. So this allows them to maintain and verify their integrity and authenticity of their content, and provides trust and transparency needed to combat the misinformation in the digital landscape. It's totally serverless, so they don't pay for it when it's not being used, but it also supports a sudden spike in content processing. So with that, I'll hand it over to Patrick for a demo.
Awesome. All right. Thanks, Jonathan. So what we'll do now is we'll start off with the demonstration. We'll have a look at C2PA in action, and then we'll take a step back and look at the services that are actually making this happen. So on that note, can we play the video? And then what I'll do is I'll do a walkthrough of a prototype that we actually delivered not that long ago with the intention of making this open source. So this is a fully built user interface that leverages C2PA. As you can see from the demonstration here, the first thing we're going to do is we're going to upload 3 different assets. A little hint, one of these assets does not contain C2PA. One of them contains a series of ingredients, which we'll talk about. And then the final one there is actually a crop file. It's not validated. So the first asset we'll have a look at is really going to be that top one there. When we click into it, you'll see that we're actually leveraging the C2PA JavaScript SDK. You can see right away, without the need of a backend, this SDK is capable of detecting whether an image has or does not have C2PA data. So in that case, that image did not have C2PA, and we can verify this with this external tool that's also taking place to verify that there's no C2PA. Now, the second asset here, which is a bit more interesting, does contain C2PA data. It actually contains seven different ingredients of C2PA data. We can see here that immediately there's no validation errors, proving to us that this is a bit more secure. And we can inspect the active manifest to discover information such as who produced this. So we can see Adobe was the last producer. We can see the algorithm being PS256, the issuer being a test certificate, and a claim generator. But what's more important to us is really the assertions here that illustrate that in this iteration of this image, we have seen elements of color adjustment. We've seen that this has imported a pre-existing content of a file, and the list really goes on in terms of assertions. Now, if we wanted a bigger, detailed version of this, we can get the full manifest itself. Within this manifest, we can dive deeper into information such as a bit more on signature and the ingredients, of course. So we can see immediately from here that there are a series of assets known as ingredients that have contributed to the ultimate generation of that final image. And we can dive deeper and deeper to the point where we can actually see that highlighted asset there does not contain C2PA data. Now, what we've also done in this project is given a bit more of an interactive map. If you don't want to look at that JSON, here's a visual of what's going on. We can see at the very root, all of those assets labeled A, built up, edited, so that ultimately it forms that final asset at the top there. Now, the final example we'll have a look at is an asset that's actually not validated. So we see immediately using the JS SDK that this asset has its own series of errors. We can see right away that there might be a mal-configured timestamp, and actually one of the assertions have been modified. Immediately, as a trusted entity, you can take that step back and say, there's something not right about this asset. It's been tampered after it's been changed from the original intender. Now let's go and actually do a live demo of creating a C2PA asset. So you can see here that I've selected the asset with no C2PA data, and using the UI, I'm going to make a few modifications. So you can see right away, these are the assertions or actions that will be meshed into the asset when it's created. We can customize it in this parameters section to illustrate whatever we want. In this case here, you can see that I've illustrated it as to what's going on. Once we're ready, we can then give it a title. I'm going to call it modified. And then we have a choice of running this with Lambda or Fargate. These are AWS services that I'll talk about later, and which have their own pros and cons. Now that we've created the asset, let's go have a look at what this asset has actually done. So we click into modified. We can now see that it's a C2PA asset with no validations, and within the interactive map, we can actually see that it's taking that source asset and now produced it. Looking at the manifest, we can decipher details around what was used. So in this case, we used the Python SDK, which is actually built on top of Rust. C2PA is built on top of Rust. We've used, once again, the PF256 test asset, and we can see that sole ingredient being hashed in. When we go to assertions, which is the more important part, we can see who created it, and then we can see right there all of the actions that we recorded previously have now been brought in and created into this asset. Now, the last thing for this demo is let's look to see what this looks like from a consumer's perspective. So here I'm going to select two images, one with no C2PA data on the left and one with C2PA data. We're then going to simulate this on a page. This is just a demo page, but what's more important about this page is the image illustration. So we can see here that this is an image with non-C2PA data. What makes it different is this little tag up the right here. This is provided an SDK, open source once again, but it links to this external tool. So you can see right away the difference between a non-C2PA, a C2PA, and we can inspect as to what's going on from a consumer's perspective. Now, I'm going to do one more modification and bring in the app that we just created. You can see as soon as C2PA is detected, we have that almost verified tick, and we can go into this tool or our own tool to further inspect what's going on with that asset behind the scenes. So that brings us to the end of the demonstration. Once again, Jonathan did mention we currently have this open source. I do encourage you all to experiment and try it out. The demo you just saw, this was a prototype that just finished last month. And we have intentions of making that open source for you all to play and to run these workloads on AWS. So on that note, we'll go to the next slide, and let's have a bit more dive into the services that are being used. You would have recalled that I said there was two compute services that were primarily being used. We're going to have one look at the Fargate option, and then we'll have a look at Lambda. For those who are not aware, AWS Fargate is a service that operates on AWS. It is a container service where you can bring your Docker file, place it onto this service, and enjoy the liberties of having scaled container compute operate on the cloud. It does have a persistent cost, which is more of a maintenance abstraction compared to its counter Lambda. However, It is a bit different to another service you may have heard called ECS in the sense that you don't maintain the instances underneath the service. So you simply specify the memory, CPU, etc. And then Amazon will do as much as possible to maintain the operations of that service. And this is what we're doing here. When we invoke that C2PA call mechanism, we are triggering Fargate to compute, use the C2PA Python SDK to then create that asset. This compute sits behind an internal ALB, or application load balancer, therefore only being exposed internally to other resources within the VPC. How we are triggering that in the UI is we're using AppSync that invokes another service called Lambda within the VPC, and then it traverses the internal ALB to invoke that Fargate resource. Fargate pull its credentials or its security mechanisms, so more particularly the certificate and private key. These are two elements that are used to securely create your C2PA asset. We're storing this in another service called AWS Secrets Manager. We pull it in. It temporarily exists on the compute system so that you can create your manifest, and then it disappears, being stored in Secrets Manager. Ultimately, this whole infrastructure is exposed as an API. So whilst it was integrated into the UI, it actually lives as a separate entity. So the UI is calling this as if it's a separate microservice using a digital asset, which might be stored on S3. We do have the option of providing a C2PA sidecar. So this is metadata without the image. There's an option to do that. And the assertions, the actions that you've done to that image. It's being passed in to the compute, returns back the asset, and we're good to go. Now, the other compute angle here is then the other service called AWS Lambda. You can think of this as a function in the cloud. There is no need for any maintenance of resources underneath. What you do is you bring your code, you place it up there, and you're ready to go. Amazon extracts a lot of that processing for you. It follows the same process in that it ultimately generates that C2PA manifest. The only difference here is that there's no internal ALB. What we're using is we're actually using a function URL. This is a new feature that just came out on Lambda that allows you to directly invoke a Lambda as an external API. So that has been abstracted. We then use, instead of the credentials of the container, we then use the role assigned to Lambda to permit what resources you can leverage. Still reaching out to Secrets Manager, which contains that certificate and key, and still being that API source. The pros and cons to each side is that Lambda sometimes does have cold starts. So if you don't use it for a while, you will discover a bit of latency compared to its counterpart Fargate. Fargate has a minor persistent cost, whereas Lambda is more on demand. So you only get charged for the time you actually use the function. We do have a blog on this where we benchmark some of the time differences. In the prototype, we didn't see much difference, but each customer has different demands. We decided to offer both and let you decide what's important to you. And this is what the C2PA API looks like. So this is completely configurable, but what we decided to do was allocate some key parameters here. So you can see at the very top, the asset URL relates to the digital asset. Parent URL can be the image. Parent C2PA can be that sidecar. And then you have pre-signed asset JSON pointing to a JSON file, or you can actually include the JSON in the API itself. Now, C2PA does have a standard that typically starts in your assertions with the label C2PA dot the element you're trying to illustrate here. So here's an example, and it's a subset of IPTC, all those other standards or vocabulary. starts with the label, and then you specify the data. However, it's important to remember that you can actually introduce custom assertions too. In the case down the bottom there, we can see a reverse domain of the Amazon metadata tag, and then data being what we choose to incorporate. But we do encourage that you follow C2PA vocabulary, just because it's an ever-evolving space. They do have a specification detailed as to some of the actions that you can provide. Another thing about assertions, or just C2PA in general, is that it's a JSON LD format, linked data. You can incorporate links and references to other manifests. There's experimentation around remote manifests and not containing them here. In this case here, you can see that they are actually using the JSON LD as a context tag to those key tags there, but then it's being used further on in the file here to be able to then specify. This is one example. Common example that I see is references the other manifests too. So if you do decide to construct a full manifest, there is some linking data. Think of it almost as blockchain principles, in the sense that each manifest lives in isolation. However, they're correlated to provide traceability to each other. And then this is really the key process here of that C2PA transition. You can see that we have a parent and current, parent being the asset that has C2PA data contained to it. So it references to its own manifest store containing that parent manifest. So think about some of the example before I showed you. What happens in the editing process is you perform actions and assertions that you wish to include in this image. When you go to create that C2PA, what we do is we copy all of the content from that previous manifest into a parent manifest within one manifest store. However, the active manifest contains the current changes from your parent to current. If you want to traverse and go further back, you then traverse the parent manifest, which continues that same iterative process of linking back to previous assets. And you get that full lineage of history change to the current parent or whatever version of the asset you want to see. And here's a highlight just on the API themselves. So more specifically, the red elements there provide you the ability to provide an image with C2PA and allow the API to do it for you, or you can include a parent C2PA. So this is a sidecar. It's the concept of creating a C2PA asset without the image itself, just the metadata itself. One more thing that I wanted to highlight was on the asset itself. So the linkage between each of the assets. So in this case here, we can see an example where we're actually including the parent movie. What C2PA does, or in the process of creating that brand new C2PA asset, is it creates a cryptographic hash using the algorithm and a series of the asset itself, the hash on the assets. It creates a reference that you don't really need to know, but it's critical because on the next slide here, you can see that it actually allows you the ability to say that if there's a change to that previous asset, so let's create this manifest, and then I decide to go click 1 second, the combination of hash there, reference here, will then provide me that detail we saw in the example to say that I am confident someone changed that. And because of the C2PA's revolution or evolution, we're seeing more details, more algorithms being explored, but also new features that are currently in exploration. But you can see in this example here that that previous slide has now been transformed with C2PA behind the scenes. So you don't manage that. You simply say, SDK, do that for me, and it will spit it out for you. Just tell me the actions and edits that you performed. All right, back over to you.
Thank you, Patrick. Pretty deep dive into the technical. So we hope you all took a lot away from that and are ready to go drive it on your own. I'll put that slide back up at the end as well. But the coalition was formed in 2019, just 5 years ago, which in today's world seems like forever ago, but we're starting to really see adoption, and more people are joining the committee. and the coalition. So we do have some limitations we want to point out. And actually, if you're interested, I'm sure each of you or your companies can help, whether it's supporting the open source code Patrick is doing or adapting for a more wider spread of C2PA and across the media and entertainment ecosystem. With broader usage from content creators, platforms, and technology providers, it's going to only continue to flywheel the effect of C2PA. Recent announcements by Adobe and YouTube and others to support this it shines a light that this is something that is really gaining traction, and it's lightweight to deploy, easy to use, and easy to validate. The current specification is focused on establishing provenance for individual digital assets, media, video, images, and documents. There's still a goal to do moving video and multiple assets together linked to a common C2PA attestation. We also understand that integrating C2PA into a workflow or a media supply chain is not as lightweight as plugging in an appliance or buying a piece of software, but as it is a non-trivial engineering effort, we believe there's long-term impacts that we might not even be aware about around lines of monetization and tracking of content. And then maintaining the C2PA standard, the open source, the guidelines, requires a long-term commitment from not just the contributors, but the governing body and ecosystems, and we may see additional communities step up and try to help as well. So with that, whether you're a content creator, a platform provider, or technology vendor, your participation can help strengthen the tools and processes that restore trust in the digital ecosystem. Collaborating with AWS and other stakeholders to learn about and integrate C2PA into the workflows. You can get involved through c2pa.org or through open source or any other tools to keep pace with the developing, as C2PA keeps pace with developing innovations in content creation and generative AI. Be remiss if we didn't thank Demian Hess, our colleague, who's done a lot of legwork on C2PA and has authored a paper that we're expecting to be published soon, so you should see something later on this. And with that, thank you all very much. We hope you enjoy lunch. We're happy to take some questions in the 3 minutes we have left, and I'll put this QR code back up so you guys can get to it.
Could you enumerate what goes into creating the hashtag? What parameters?
The way C2PA has been set up is depending on the algorithm you choose. So off the top of my head, there's P at 256, there's E, S. But mainly the algorithm of selection is a core element to what forms it. The control that you have on top of it is really the certificate and key. So depending on the algorithmic hash you use, some require a more public-private key setup. Others actually need you to register with a root CA, and from that root CA, you then generate it. A lot of the hashing algorithm is abstracted into the CDK and use the cryptographic elements to be able to do that. But unless you can bring in, I've heard that they're trying to introduce new hashing algorithms too. There could be an element of custom hashing brought in. I think the key is really the output and the input rather than the programmatic sense, which is what the SDK, from my experience, I simply specify the algorithm, I provide the credentials in Secrets Manager, and then it just comes back to me. If it's broken, it will tell you. And that's how I've used it as a mechanism to ensure something's linked together or something's verified.
Yes, that answers the question. And could you talk also about the linking of, said it's currently not doing linking to other videos. What sort of work is being done there for that linking?
So we've got multiple assets. It's a known limitation. So today, each file is a unique hash. And so, in my background as a broadcast engineer, I think of multi-camera production, right? So you may want to hash all of those similarly, parent-child. There hasn't been much development in that yet because people are so focused on, let's understand C2PA and test against it and what's the impact on deploying it.
Okay, thank you.
Any other questions? Well, Pat, you're going to have to hang out by the salad bowl during lunch if you want to grab us and ask a question. Otherwise, thank you very much. Appreciate your attention and enjoy the rest of the event. Okay.